methods of polarizing and unpolarized light. So the first method which we are going to discuss is basically polarization by reflection. So guys, there was a guy named as Brewster. He basically discovered that particular thing. So let me write his observation. It was discovered that whenever a light is incident on a medium which partially reflects the light and partially transmits. So whenever an unpolarized light, whenever a ordinary light or unpolarized light is incident on a medium which partially reflects and partially transmits the light, then the reflected ray and then ऐसे नहीं लिखते हैं then first point gets partially polarized in a, in such a way that its vibrations such that most of its vibration you can say I'll draw a diagram enough to place some space for the diagram. Most of its vibrations are restricted along the plane of incidence and the reflected ray vibrates in a plane perpendicular to plane of incidence. So it means that suppose if I have a surface over here which partially reflects and partially refracts as well. So suppose if I have a light like this, so can you see guys, I have incidented it at certain angle, so a part of this light gets reflected. This is the reflected ray and this is our incident ray, है ना? Guys, is this clear?
Yes, sir.
So now, if the incident, I'll just draw the polarization a bit later. थोड़ा सा रुको. This is the refracted ray. So it was discovered that this particular thing, whenever a light ray, an unpolarized light. So can you see an unpolarized light? The arrows are also here, and the dots are also here. So can you see an unpolarized light, guys? Guys, hello. So this is an ordinary light which is incident. Then what happens to the reflected ray? In the reflected ray, this reflected ray gets partially polarized in such a way that the plane of vibration of this particular thing is basically perpendicular to the plane of incidence. You can say this particular thing, only dots is a, can you see guys, it's partially polarized, and most of the light is in basically, can you see the number of dots is basically greater than the number of arrows? Yes or no? So here, what is the most probable plane of vibration? Can you see this dots mean basically perpendicular to this plane, right? The plane in which I am drawing, that is the plane of incidence. And can you see the number of dots are more? Hence, this represents what? A partially polarized reflected ray. But here, the plane of vibration is basically perpendicular to the plane of incidence. Is this clear? So I wrote the reflected ray vibrates in a plane perpendicular to the plane of incidence. What about the refracted ray, sir? Refracted ray, it vibrates. Can you see again, the refracted ray gets polarized in, again this is a partially polarized light, and this is also partially polarized. Guys, itna clear hai? The second point I'll write in this, the refracted ray also gets partially polarized with the plane of vibration, or basically the vibrations are in the plane of incidence. Itna clear hai guys? Can you see here, the number of arrows are more, number of dots are less? Yes or no guys? Here there won't be any dot. With this dot, let's make it over. Can you see this thing guys? This the refracted ray is getting partially polarized, but the number of arrows are more as compared to the number of dots. So can you see the what is the most prominent plane of vibration, which is along the plane of incidence? Here it is perpendicular to the plane of incidence. Itna clear hai? Now, there is a guy named Brewster. What he did, Brewster said that, इतना लिख लिया, diagram बना लो guys. Write this much and make the diagram. And whenever you're done, just tell me. Guys, इतना समझ में आया?
Yes, sir.
हाँ. So now what did this Brewster guy did? ये लिख लो पहले, फिर मैं उसके बाद बताता हूँ what Brewster did, है ना? Whenever you're done writing, tell me. Today we'll finish off this chapter. So Guys, shall I continue?
Yes, sir.
Yes, sir.
Okay. Now
Yes, sir.
Brewster's did a series of experiment, and he said that the reflected light, the reflected ray from the surface becomes completely plane polarized. Matlab basically what happens if you try to increase this angle of incidence, if you try to increase this angle of incidence, what will happen? The reflected ray will also shift over there, right? And the refracted ray will also shift over there, but by certain different angle, following Snell's law and all, right? So Brewster said that the reflected ray from the surface becomes completely plane polarized when incident light is at a particular angle. Incident light is basically ordinary light, है ना? Unpolarized light is at a particular angle called as polarizing angle or Brewster's angle. So he said that when you incident the light ray in at one particular angle, then the reflected ray gets completely plane polarized. And which will be the most probable plane? And which plane will be there? Will there be dots, or will there be these arrows? So it Brewster's angle, and at this angle of incidence, it was observed that the reflected ray and the refracted ray, you write the whole thing, na? Otherwise you will get confused, such that the reflected ray and the refracted ray are perpendicular to each other. So basically guys, what am I trying to say? This particular thing is like, you don't need to draw this diagram again, है ना? I'm just drawing this diagram for comparison. So at one particular angle,
So,
mhm,
can you scroll up a little
sure.
to the diagram?
Achha, by the way, this statement which I have written in red is basically called as Brewster's law.
Thank you, sir.
So basically guys, can you see I increase the angle to a particular angle of incidence known as the Brewster's angle, IB. Is it clear? IB or IP, whatever you want to write. At this particular instant, this refract angle of reflection is also angle of reflection is also equal to IB, right? Yes or no? This angle of reflection is also IB, and this is basically angle R. And they have found at this particular angle, when the angle between the reflected ray and the refracted ray becomes 90 degree. When the angle between this ray and this ray becomes 90 degree at this particular time, if you at this particular angle, if you incident a unpolarized light. So guys, are you able to see an unpolarized light over here? Can you see an unpolarized light is over here? So when this happens at this particular angle of incidence, ये वाली light gets completely plane polarized. So this is plane polarized light. Whereas the refracted ray में, the refracted ray is still partially polarized, है ना? But can you see the degree of polarization has increased? Yes or no? At angle of incidence equals to the Brewster angle, reflected ray completely plane polarized, and refracted ray is still partially polarized with a higher degree of polarization. Is it clear guys? ये समझ में आ गया क्या? Guys, you understood this particular thing? If I incident a
Yes, sir.
ordinary light over here at the Brewster's angle, then what will happen? The reflected ray will be completely plane polarized and the refracted ray will be partially polarized, but the degree of polarization will be a little bit more. Is it clear? So the law generally states only for these two rays, the incident ordinary, and can you see by the reflection phenomena I have completely plane polarized the light. Are you getting my point? So this is called as polarization by reflection. Is it clear? So if
So,
this
so what is this IB?
IB is called as the Brewster's angle. IB or IP. You can write it as polarizing angle or Brewster's angle. It's up to you. Okay.
Okay, sir.
So now see over here, guys. If this angle, the angle between reflected ray and this is 90 degree, can I say this angle plus this angle? Oh, sorry, this angle plus this angle. If this is 90 degree, the total is 180 degree. Then can I say this R plus IB is 90 degree?
Yes, sir.
So can I say IP plus R is equals to 90 degree? If it is 90 degree, then can I say R is basically equals to 90 minus IB? This is coming from the diagram, है ना? Is it clear?
Yes, sir.
So after this, can I apply Snell's law? Suppose guys, this is medium mu1 and this is medium 2, है ना? Medium 1 and medium 2. Refractive index is mu1, mu2 respectively. So can anyone apply Snell's law? Can I say mu1 into sine of IB is equals to mu2 into sine of R? Can I say this? If I can say this, can I write sine of IB divided by sine of R, and R I can write as 90 minus IB is equal to mu2 upon mu1. Can I say this? And what is this? Refractive index of medium 2 with respect to 1, right? Yes or no? Yes or no, guys?
Yes, sir.
So what is sine of 90 minus theta? Cos theta, right? So this becomes sin IB divided by cos IB is equals to 1 mu 2. And what is sin by cos?
Tan.
So you can find out IB using tan inverse of this, or tan inverse of mu 2 by. This is how you calculate your polarizing angle for any medium. Is it clear? Please remember there are certain points which you need to remember. है ना कि the reflected polarized light has vibrations perpendicular to the plane of incidence. है ना? I'll write it. Don't worry. Guys, ये लिख लो फटाफट derivation, and once you're done with the derivation, then we'll write certain points. And this is the derivation which is important to school, है ना? Done? Yes, guys, done. Are you done noting now?
Yes,
Yes,
sir.
sir.
ठीक. इसमें दो points you need to, तीन points you need to understand very carefully. First is the reflected ray gets polarized in a plane, or polarized in the plane of incidence. You can say it gets polarized in the plane of incidence, or you the plane of incidence, or you can write it has vibrations perpendicular to the plane of incidence. Check. First point is this. Second point is the degree of polarization increases as the angle of incidence is increased, and that is when we are talking when the angle of incidence is basically less than the Brewster's angle, right? So if the angle of incidence is less than the Brewster's angle, then you increase the when you increase the angle of incidence, automatically the polarization gets clear. Is this clear, guys? Is this clear? Maximum कहाँ पे होगा? Where is the maximum degree of polarization? Guys, where is the maximum degree of polarization? It is at
IB equals to IB.
I equals to IB. ठीक है, 100% पोलराइज रहती है. third point you can write, the Brewster's angle, it depends on wavelength. Generally, it depends on wavelength. So for complete polarization, we use monochromatic lens. For complete polarization of the light, we use monochromatic lights only. Enough. If you want 100% plain polarized light, is this clear? Is it clear, guys?
Yes, sir.
Acha, sometimes people can this thing you written, no, mu equals to tan ib. ये इसको भी people they call Brewster's law, right? So generally they define the tan of the Brewster's angle is basically equal to the relative refractive index of the. So basically this is the mathematical form for Brewster's law. ठीक? Is it clear, guys? Guys, is it clear?
Yes, sir.
ठीक. The second method which we are going to discuss is basically polarization by refraction. Sir, refraction से भी polarization होता है क्या? Yes, it happens. Polarization by refraction. अब suppose guys, I have a light ray, है ना? Generally ये method use नहीं करते हैं. We don't use this method because the intensity of the coming polarized light is very less. So that's why generally we don't use it. Control C, Control V, and Control V again. So suppose guys, क्या किया मैंने? We just learnt this particular thing. कि suppose if I have a light ray which is coming like this, what will happen to this light ray? It will get reflected and it will get refracted, right?
Yes.
Then what will happen? Suppose this angle of incidence is not equal, for TIR, total internal reflection is not happening. TIR not happening. Suppose I'm just giving an example के रूप में. So this light ray will come like this. After getting reflected, it will come like this. Yes or no? It will again
Yes.
reflect back and refract. Yes. Again come over here, again reflect and come back. So guys, and this will come out finally out, है ना? So guys, suppose this is just what we have learnt as of now, na? Just right now जो we have learnt. So suppose this is an unpolarized light which is I'm sending over here, right? So I told you this particular thing. If I introduce it to if I incident it at an angle of Brewster's angle, then this ray will get completely polarized, right? So suppose I have incidented at an angle of Brewster's angle. Yes? Yes or no, guys? Yes or no?
Yes, sir.
So it will emerge out of the same angle, Brewster's angle, right? इतना सबको पता है या ना? And it will get incident on the same block with the same angle because of alternate interior angles. तो अब जरा गौर से देखो what is happening है ना? When I incident a light on a glass slab with at an angle I equals to IB, the reflected ray gets completely polarized, but this ray will get partially polarized, right? Yes or no? So suppose now here two dots are there and four arrows are there. Now what will happen to these two dots? I will not let this ray go. I'll pass it through another glass slab which is placed parallel to all these things. So what happens ki when I place this, now this is not incident, this incident light on the second slab, the incident light on the second slab is not ordinary light, no, it's partially polarized light. Yes or no? So partially polarized भी हुआ तो भी क्या होगा, this thing will give away. Suppose थोड़ा सा और ऐसा dot, let's say initially four dots and four arrows are traveling, and what happened, two dots went along the direction of reflected ray. So now there are four arrows and two dots traveling. Then again we use the second slab to refract the light. So what will happen? Now two dots will travel this way, and what will happen? Hello?
Four arrows will remove.
And four arrows will travel like this. So now it will become a completely plane polarized light. A completely plane polarized. So here what will happen? Here there will be no plane. It will be the same thing as like this. Two arrows will go now. Are you getting my point?
Yes.
Yes or no? तो तीसरे की तो जरूरत भी नहीं है. So let's remove it. So guys, can you see, by using multiple slabs in parallel with each other, I can do this particular thing. I can limit the plane of reflection. इसको तीन चार बार और करूंगा तो what will happen? I'll get a completely polarized light, right? I'm getting a polarized light over here. I'm getting a polarized light over here. But can you see the difference in the planes of vibration? Yes or no? So we can write
Yes,
by
sir.
using multiple glass slabs parallel to each other, we can polarize a light, unpolarized light. We can polarize an unpolarized light in the planes same as the plane of incidence. So basically this process is called as the polarization by refraction. Are you getting my point? I'm not concerned about this polarized light which is going due to reflection. I'm concerned about only this polarized light which is coming due to refraction. Are you getting my point? Yes or no? So can you see
Yes,
guys,
sir.
the final emerging light which comes, it will have the plane of vibration in which plane? The plane of vibration will be same as the plane of incidence. Final emergent wave has a plane of vibration in the plane of incidence. Is it clear?
Yes, sir.
This is polarization by refraction. Now there is something called as polarization by double refraction as well, polarization by dichroism as well. So बहुत बहुत चीजें हैं, but अभी इतना वो नहीं है. We don't require that much in polarization. Last is polarization by scattering. So guys, basically what is scattering phenomena? See, the scattering and the Tyndall effect which you have seen, if I go to the quantum uh, explanation of what exactly is happening. So suppose there is a particle, है ना? This is a dust particle or whatever particle it is, and let's say on this particle I'm introducing a I am sending an unpolarized light over here on this small very tiny particle. whenever tiny particles are involved, then quantum phenomena we consider there as as a quantum phenomena. So you can say in scattering, the incident light is absorbed and then re-radiated. What do you mean by re-radiated? मतलब what से मैंने क्या किया? Absorb किया and then I emitted it out again, right? So in scattering, the incident light is absorbed and then re-radiated in different directions by a particle of size comparable to the wavelength of light. So if you have a very tiny particle, then what will this tiny particle do? What will this tiny particle do? It will absorb this incident ray and then send uh, this thing in all certain direction, in different direction. So it was observed that when this thing was done, when scattering is happening and polarization by scattering is happening, then okay, let's say guys, this is the initial direction of propagation, है ना? This is the direction of propagation of the incident light. So guys, when this unpolarized light, which was absorbed and then re-radiated by this tiny particle, then it got split into three parts. It was observed that the in the direction which was similar to the initial direction of propagation, the light ray becomes partially polarized. Can you see guys the initial direction of propagation and this thing? This is the final direction of propagation. From unpolarized, it become polarized over here. In the remaining two axes, can you see in this axis and this axis, both all of them are perpendicular to each other and mutually perpendicular. X, Y, Z. Are you getting my point, guys? Suppose this is positive X and this is negative X, and the light ray is coming from negative X. So in Y and in Z, so let's say in Y, what happens? It becomes polarized in one particular plane, completely plane polarized, and in Z it will be completely plane polarized. But can you see the plane of polarization? It will be different. So if towards positive X direction is the initial direction of propagation, then after scattering along the positive X direction, you get a partially polarized light, and along plus Y and plus Z, you get a completely plane polarized. But what will happen if along Y you are writing all the dots, then along Z you will write all the arrows? Is this clear?
So can it be the other way around?
It can be the other way around as well. If along Y it's arrows, then along Z it will be dots. Is it clear, guys? But in the direction of initial direction of propagation, it is always a partially polarized. So again, can you see this phenomena is called as what? It's not necessary कि sir this light ray is getting distributed in three parts only. Nahi. It's re-radiated in all possible directions. Are you getting my point? But those light rays which were along plus x plus y and plus z, we are telling specifically about those. Is it clear?
Yes, sir.
So these are your three different methods for polarization. Clear, guys? Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
ठीक है. Last heading for today, and that will be the end of this chapter. Law of malice. Law of malice. So, guys, first of all, we know this particular thing that whenever you have a Polaroid or a basically, polarizer, these materials are basically called as Polaroids. So, anyways, so we know this that whenever there is a ordinary light which is passing through a polarizer, then only those vibrations will pass which will have, the intensity vibrations which are along the crystallographic axis, right? Only those vibrations are allowed to pass, right? Initially the vibrations
Yes,
were in all possible direction, and when this light passes through a polarizer, what happens? you know the only those vibrations are allowed to travel which are along the crystallographic axis. ये अपने को पता है, right? आया ना? अरे shall I draw it? Suppose this is a polarizer, and let's say this is the light ray which is going, and this is the transmission axis or the crystallographic axis, right? So if I initially have a unpolarized light which has vibrations in all possible directions, so basically what will happen when these light will pass through the Polaroid? What will happen? They become completely plane polarized, and only those plane of vibrations are remaining. Only those vibrations are remaining which are along the direction, along the crystallographic axis, right? So can you see remaining all vibrations they got polarized, right? Yes or no? ये अपने को पता है, हाँ या ना? So if I say the intensity of ordinary light, this is ordinary light, this is I naught, then I'll tell you this particular thing. This is not the law of malice, है ना? Law of malice जब भी आएगा, I'll tell you. So intensity of ordinary light is basically this becomes and this intensity of this plane polarized light, this is the plane polarized light. If I say the intensity is I naught and if I say the intensity is I dash, then clearly you have seen this phenomena, by the way. If you remember the video which I showed you when the guy was holding a torch, and when he introduced the uh, Polaroid in front of it, then the intensity suddenly decreased, right? Yes or no? So the intensity of this polarized light will be lesser than the intensity of original light. By the way, for your information, I dash is equals to I naught by 2. है ना? The intensity reduces to half. Hello guys, ये समझ में आ रहा है? ये वाला do I need to give a derivation for this? Guys, shall I give a derivation for this? Is it fine? You accept what I'm saying? अरे बताओ,
Yes, when
एक्सेप्ट
we
करते
take
हो
the
तो आगे
average
बढ़ूं
of
मैं.
cos square something, right? Cos
हाँ
square
हाँ
theta.
हाँ, आई नो आई नो
हाँ
आई
वही
नो
है,
आई नो.
right?
अभी law of malice will come when you will have a plane polarized light pass through this polaroid. Okay, ordinary lights
All
through
right.
plane polarized light, it's not applicable, but law of malice is applied. You'll write is applied when a plane polarized light passes through a polarizer. So basically you are not passing this in through the polaroid in the case of malice law. You are passing this through another polaroid over here. Are you getting my point? So law of malice is applied when a plane polarized light passes through a polaroid in such a way that the plane of vibration of the plane polarized light makes an angle theta with the crystallographic axis of a polaroid. Okay, so suppose guys, this is the plane polarized light, and I am passing through this a second polaroid. So guys, can you see? मैं थोड़ा सा आपको yes guys, can you see me?
Yes,
Suppose
sir.
this is the plane of vibration of the polarized light. So matlab basically the light, the vibrations are only along this plane, right? This is my polarizer which is placed like this. So can you see the plane of vibration, this one, right? And can you see the crystallographic axis is like this? Up suppose if I tilt this thing, if I tilt this polaroid by a certain angle theta, so now can you see the plane is like this, the crystallographic axis is like a little bit टेढ़ा, ऐसे नहीं, सामने देखना है ना. इनिशियली इट इज लाइक दिस. अरे यार मैं कैसे दिखाऊं, ऐसे दिखेगा नहीं. So initially it's like this, now I'm doing it like this. Guys understood?
Yes, sir.
Yes, sir.
So basically what I'm doing, this is the plane of vibration. Initially the light rays were along the plane of vibration. Now I'm moving the crystallographic axis. So can you see an angle theta?
Yes,
Can,
sir.
so this angle theta is basically that theta which I was talking about. Is it clear? Is it clear
Yes,
guys?
sir.
ठीक है.
Yes, sir.
Let me connect it back again. ठीक है. then these light rays which will come out, it will have a further reduced intensity, but they will be having a plane exactly same to the crystallographic axis. Can you see, guys? The intensity of these light rays will be further less. So now suppose if I am introducing this as I naught, and this is I dash, then according to the law of Malus, if the intensity of this light is, and this, both are plane polarized, guys, but can you see the planes are different? Guys, can you see the if a plane polarized light is passed through a Polaroid in such a way that the plane of vibration makes an angle theta with the crystallographic axis of the plane, then the new or basically the emergent light will also be plane polarized, but the plane will be restricted only along the crystallographic axis direction, right? So if this was the new direction of crystallographic axis, then these plane of vibration will be along the same thing, and the intensity is I dash. Then according to the law of Malus, when a completely plane polarized light of intensity I naught is passed through a Polaroid in such a way that its plane of vibration makes an angle theta, ये अपन लिख चुके हैं ना, makes an angle theta with the crystallographic plane, with the crystallographic axis, then the intensity of the emergent wave, the intensity of the emerging light is directly proportional to the square of cosine of angle theta. ठीक है? और ये in spite of writing angle theta over here, you can write the intensity of the emerging light is directly proportional to the square of cosine of the angle between the vibrational plane and the crystallographic axis. This is called as your Malus law. ठीक है? Is this clear? This is called as Malus law. It says matlab, basically this intensity I dash. Can you see the guys? This I dash, this intensity I dash is directly proportional to the cos square theta, cos theta whole square, or cos square theta, right? Acha, by the way, when you remove the sign of proportionality, introduce a constant. That constant is equal to what? The intensity of the incident wave. That's the maximum possible intensity, right? So I dash is equal to cos square theta. This equation is called as equation of Malus law. Clear hai? Guys, is it clear? I dash is basically equals to I naught cos square theta by 2. Guys, ये वाला point याद रखोगे क्या? कि when you pass an unpolarized light through a Polaroid, then its intensity becomes I naught by 2.
Yeah.
है ना? And when you pass a polarized light but through a polarizer with an angle theta, then the plane polarized light becomes I dash. I dash is equals to I naught square, cos square theta. Here the I naught is what? The intensity of the plane polarized light, plane polarized incident light on the Polaroid. And I dash is basically the intensity of emergent polarized light. By the way, please remember it's cos square theta. हमेशा याद रखो I dash will be less than I naught. Always. I dash will be less than I naught. When you pass it through a polarizer, intensity का घटना तय है. The max to max case, it's basically it remains equal. है ना? अच्छा, जैसे case 1. If I say theta is 0. If I say case 1 theta is 0, that implies if you have a light and if you have a polarizer, and can you see the angle is like this, crystallographic axis is like this, and you know this is also like this, right? Then what will happen to the intensity? Can anyone tell me what will happen to the intensity? Will it decrease or will it increase?
It won't change.
It won't change, it will remain the same. So if this is I naught, this will also be I naught. Here I dash, when theta is 0, cos 0 is 1, and I dash is equals to I naught. Is this clear? So no change in intensity of plane polarized light. Case 2, if theta is equals to 90 degree, then I dash will become 0. That implies if you have this light ray and you rotate your Polaroid like this, can you see guys? Now the plane of vibrations were along x-axis and this is along z-axis, right? The crystallographic axis is along the z-axis. So can you see when the light ray will come, it won't have any intensity. So can you see, you won't be able to see anything, black, completely black. Are you getting my point? Understood guys?
Yes, sir.
ठीक. अच्छा, either it is 0 or either it is 180, doesn't matter, है ना? When you place it like the ulta as well, then also it won't matter. So that's why that guy was only rotating it till 90 degree, right? समझ में आया? So anyways guys, this is your analysis law. Shall I give you one question based on this? Shall I tell you the reason why it becomes when you pass an unpolarized light through a Polaroid, it becomes I naught by 2, right? You know why? You know why? Because suppose if this was at a general angle theta, then this would have been the intensity of this light, right? What is the average value of cos square theta? Guys, can anyone tell me what is the average value of cos square theta? What is the average value of cos theta and sin theta? The average value of cos theta and sin theta, it's 0. Average value of cos 2 theta, sin 2 theta, 0. But average value of sin square theta or cos square theta, it's 1 by 2. The average value of cos square theta is basically 1 by 2. Maths people might relate it. So basically what happens is when you pass an ordinary light through this particular thing, we say that the average intensity of the plane polarized is basically reduced to half, because you use small element and you integrate and you finally get the answer as I naught by 2 average value. Is it clear? इतना क्लियर है guys? Shall I give you one question?
Sir, can you repeat what is when it is 0 and when it is 1/2?
जब भी स्क्वायर हो, साइन थीटा, whenever it is sin theta cos theta 0, sin 2 theta cos 2 theta या फिर 3 theta and so on, it is basically again 0, but whenever it is square it's 1/2, है ना? Whenever
Okay,
it's
sir.
square, the value will lie between 0 and 1 only. Otherwise, whenever it was sin theta and 1, the value was lying between -1 and 1. So इनका average value is basically 0 and इनका average value is basically 1/2. Are you getting my point?
Yes, sir.
So that's a little, maths people might relate it much more better, but it's okay. अपन याद रख लेंगे, ठीक है? I'm giving you one question. An ordinary light was passed from two ordinary light of intensity I naught, of intensity I naught passes through two polarizers, two Polaroids, the in succession, ऐसा लिख लो, two Polaroids in succession. The angle between the crystallographic axis of the two Polaroids is 60 degree. Find the intensity of emergent light. किसी को क्वेश्चन समझ में आया? So suppose guys there are two Polaroids and let's say, अच्छा, I'll just draw the axis, है ना, transmission axis. I'm not drawing the whole thing. ठीक है? This is the transmission axis of first one, and this is the transmission axis of the second one. Basically, the angle between them, they have given it as 60 degree, and they are passing a ordinary light of frequency how much? Ordinary light of intensity I naught. So you need to tell me what is the intensity of this wave. You understood the question? Guys, is it needed? If shall I draw the polarizers? It's fine.
It's fine, sir.
Check it. So find out what is the intensity. Your options are. Let me calculate it first. है ना?
Could you just show the whole question once? Okay. Thank you, sir.
These are all your options, guys. जल्दी बताओ. First of all, guys, you are passing an ordinary light through a polarizer. The intensity will be
I naught.
by 2. Ordinary light pass through a Polaroid, the intensity will decrease by 2.
Yes, sir.
है ना? ये क्वेश्चन जेई में पूछा हुआ है, इसलिए मैं बोल रहा हूँ भाई. Are you getting my point? Ordinary light pass through a Polaroid, intensity will decrease by 2. Now what is the initial intensity? I naught by 2, and now you need to find I dash. So can I say I dash will be equals to I naught by 2? समझ में आया? cos square theta or cos square 60. You remember I told you, no, I naught is basically the incident of the intensity of the incident polarized light. So the intensity of the incident polarized light is basically I naught by 2. So you need to solve it.
So always intensity is I naught by 2.
क्या भाई?
It's always I naught by 2 after polarizer.
हाँ, मतलब कभी whenever ordinary light is getting passed through a polaroid, it becomes I naught by 2.
Okay.
Ordinary light becomes plane polarized, so intensity decreases. है ना? Ordinary to plane polarized, I naught से I naught by 2. Plane polarized से plane polarized, the plane will be like this at an angle 60 degree. Understood? The plane will be like this, and here the plane will be both. Are you getting my point? ये सबको समझ में आ गया question?
Yes.
So the intensity of this polarized light will be equals to cos 60. कितना होता है? Cos 60 is 1 by 2, right? 1 by 4. So this will be I naught by 8. Generally people will take this as their answer because they will write I naught over here and your answer will become wrong. And ये mistake बहुत लोगों ने करी, पिछले साल ही करी थी शायद. It's maybe past to past year or past year only. So this is your answer, not this. Is it clear? Understood?
Yes, sir.
ठीक. So this is it about your polarization, and that's all for wave optics. Any doubt in wave optics? ठीक है? चलो. Let me just stop this recording and I'll start recording again for photoelectric effect. Guys, is it clear? First I am completing till JEE mains level. I told you already this particular thing, right? Hello?
Yes, sir.
Yes,
Do you
sir.
remember in Young's double slit experiment I made you leave some pages? We'll cover all those things, but later, once I'm done with your whole syllabus. Acha, what is the chapter which is currently going on in your school?
So we are done with the portion.
Done with the portion.